Rational and irrational numbers together form real numbers. Irrational numbers is the topic in this video. Very warm welcome to viewers at Raj-J's channel. We know that rational numbers can be expressed in the form p by q. P and q are integers and q not equal to 0. Irrational numbers are those which cannot be expressed in the form p by q as above. Root 2, root 3, pi, root 15, etc. are examples of irrational numbers. To understand more about irrational numbers, let us understand decimal expansion of real numbers. 3 by 4, its decimal expansion is 0.75. For 7 by 8, we have 0.875 is a decimal expansion. These decimal expansions are called terminating because after some steps in division, the remainder becomes 0. Now in these two examples, 10 by 3 decimal expansion is this. 3 quotient continues. In this decimal expansion, 142857 is repeating and it continues. Decimal expansion of 10 by 3, the digit 3 keeps on repeating. Remainder never becomes 0. We write 10 by 3 as 3.3 bar. This bar means 3 is repeating. In decimal expansion of 1 by 7, digits 142857 keep on repeating as a block. 1 by 7 equal to 0. In this block we put the bar on top, meaning that all these units in block are repeating. We say decimal expansions of 10 by 3, 1 by 7 are non-terminating, recurring. Now decimal expansion of root 2 and pi, it is written over here. We often take pi equal to 22 by 7, but this is an approximate. Its real decimal expansion is this. Decimal expansion of root 2 and pi are neither terminating nor non-terminating recurring. Such numbers are called irrational numbers. We can say that irrational numbers have non-terminating, non-recurring decimal expansions. Rational numbers have decimal expansion either terminating or non-terminating recurring. All irrational numbers can be represented on number line. Root 2 and root 3 have been represented here in the number line. This is 0. This is 1 unit we take here. We draw a perpendicular here measuring 1 unit. We join O and P. So in this right angle triangle, OP will measure root 2 as per the Pythagoras theorem. Again, if we draw a perpendicular of 1 unit here, the length OQ will be root 3. And with OP as radius, if we draw an arc, it will meet number line at M. With O as center, if we draw arc with OQ as radius, it will meet N on the number line. So OM is root 2, is the measure of root 2, and ON is the measure of root 3. To represent or find value of say root 3.4 geometrically, we draw a line PQ with length 3.4 units. We take QR as another line segment measuring 1. Then we take the midpoint of PR, which is O. With OR as radius, we draw a semicircle. Then with Q, at Q we draw a perpendicular on the line PR, cutting the semicircle at T. So TQ or QT will be equal to under root 3.4. With Q as center and QT as radius, if we draw an arc, it will cut this line at E. Now if we take Q as the 0, then QE will be the measure of root 3.4. The sum and difference of a rational number and an irrational number is irrational. Like 3 is a rational number, root 2 is an irrational number, 3 plus root 2 is irrational, 4 minus root 5 is also irrational. Product of rational and irrational, 4 root 5. Division of rational by irrational, all these are irrational numbers. But if we multiply, if we add, subtract, multiply or divide two irrationals, only irrational numbers, the result may be rational or irrational. Like 3 root 2 into root 2 is equal to 6, but 4 root 5 into root 2 is 4 root 10. Now we define radicals here. B to the power n is equal to a. We can write b equals a to the power 1 by n. A, b are rational numbers and n is positive integer. This we can write as nth root of a. N is called index and a is called radicand. These are the examples. 3 square is equal to 9. So 3 equals 9. This 2 comes here as 1 by 2. We can also write this as under root 2, under root 9 and 2 here. 2 is the index. And we can simply write root 9 because for square roots 2 is not necessary to write. This root means 2 is the index. Radicals of index 2 are known as square root radicals. This 100 root over 108, 108 will be written as radical 6 root 3, not 36 root 3. Root 75 is 5 root 3. Rationalization of denominator. The denominator, wherever denominator is irrational, we have to make it rational. So this is called rationalization of denominator. So to make this denominator rational, we multiply root 2 to the numerator and to the denominator and we get root 2 by 2. Another example, 1 by 2 plus root 3. We multiply denominator by 2 minus root 3 and numerator by also the same number. This a plus b, a minus b form. So we simplify it and we get 2 minus root 3. Another example, simplify root 5 plus root 2 whole square. A plus b whole square formula is applicable for irrational number also. So this is root 5 square plus 2 ab plus b square. Root 5 square is 5. Root 2 square is root 5 square is 5. Root 2 square is 2. So 5 plus 2, 7 plus 2 root 10. Here we have to find three different irrational numbers between 5 by 7 and 9 by 11. Decimal expansion of 5 by 7 is this, and that of 9 by 11 is this. Three different irrational numbers can be written like this. We can have any choice of your liking, but we have taken here, like what we do is 0.71, we put 1 0 here, then after 4 2 we put 2 0, then after this 4 2 we put 3 0, and like this. Similarly we begin with 0.72, 042, 0042 and 3042. Then we start with 0.79. You can start with 0.78, 0.77, anything like that. So 0.79 we put 0, 042, 0, 042 and 3042. This is all about the irrational numbers. Thank you very much for watching this video patiently.